My name is Sam Shaver, and today I will be doing some problems from chapter 12.7 on law of sines. Okay, so the law of sines should be used when given information about three measurements of a triangle and should be used to determine the other measurements that are unknown. So this is the formula. And you obviously have your angles here and then your side lengths here, and you just plug it in and set two of them equal to each other, whether it be those two, or these two. And that way you can determine the unknown, which could be any of these. Okay, so now let's start with some example problems of the law of sines. So for our first problem, these are the givens. C equals 12, angle A equals 42 degrees, angle C equals 69 degrees, and we are trying to find A, side A. So first let's draw a picture. So this is side C, so this has to be angle C, so this is 69 degrees. This can be A, so this can be 42 degrees. So now you have to utilize this information and plug it in to this formula seen before. So you do side A over the sine of angle A. So side A is the unknown, so it would be x or A or whatever variable you want to use, over sine 42 degrees equals 12 over the sine 69 degrees. So now you plug this into the calculator. Well, first you have to isolate x, so then it becomes x equals 12 sine 42 over sine 69. So now you have to use your calculator and you plug that in. 12 sine of 42 degrees divided by sine of 69 degrees, and your answer comes out to be 8.6, and that equals A. So that is the first answer for this problem. Okay, so this is another sample problem having to do with the law of sines. So this one, C is given as 35. Angle A is given as 38 degrees. And angle C is given as 102 degrees. But our unknown in this is B. Unknown. But we do not have an angle measurement for B. So everybody should know by now that all the angles of a triangle add up to 180. So we should be able to find the angle that is B by adding these up and then subtracting 180, or 180 minus whatever we get from this. So 102, 38 equals, so 140 minus 180 minus 140 equals 40. So that means that angle B equals 40 degrees. So now we go straight back in and use this formula. So we're looking for B, so now we can completely ignore that once we have B. So it should be x, or whatever variable you want to use, over sine of 40 equals 35 over sine of 102 degrees. So once again, you multiply that over to get the x by itself. So it would be 35 sine 40 over sine 102. Once again, plug this into your calculator. I guess that equals x. 35 sine 40 divided by sine of 102, and you get exactly 23 for that. So that is your side B length right here. Okay, so this is problem number 3 of the law of sines. So this problem, two angles of a triangle measure 32 degrees and 53 degrees. The longest side is 55 centimeters in length, and the goal is to find the shortest side. So let's draw it. If we were to have a triangle like this, so this would be 32 degrees, 53 degrees. To find the third angle, all you have to do is add these up and then 180 minus whatever this is. So these added up are 85, so 180 minus 85 equals 95, so this means that this is 95 degrees. So the longest side is the one across from the largest angle. So this is the largest angle, so this would mean that this is the longest side. So this would be 55. The shortest side would be the one across from the smallest angle. So since this is the smallest angle, this would be the shortest side, even though it doesn't really look like it with the triangle. So this would be what we're trying to solve for. So just, this doesn't matter, but let's just make that A, and this equals side A, angle A, then angle B, and then side B. Okay, so once again, just like every other time, we use this formula. So we just plug in what we have here. So we'd have 55, which is the longest side, over the sine of 95 equals x, which is the unknown, which is the smallest side right here, across from the smallest angle, over sine of 32 degrees. So once again, just like every other problem, you have to isolate x. So it'd be 55 sine 32 all over sine of 95. So to put this in the calculator, you get 29.25, and this equals the shortest side length. So that is your answer. Okay, so this is problem number 4, and it's a word problem, still having to do with the law of sines. So this is the problem. To find the height of a tree across a river, Carlos laid off a baseline 70 meters long and measured the angles shown. He found the angle of elevation of the top of the tree from A to be 10 degrees. How tall is the tree? So this would be 10 degrees right there. So this says 51 and this says 82. They're kind of hard to read because they're small, but and then this is 47. I figured that out just from the rule that we used earlier, where all the angles add up to 180 in a triangle. So I just added these up, subtracted 180, got 47 there. So our goal is to find this. So first you have to do the law of sines to find this side right here. So you can do, once again, using these formulas, just like every other problem. I'm going to kind of do this on a new piece of paper to where you can still see this thing. So this is B, this is angle B, this is side B is what we're trying to find. So that will be the unknown over the sine of 51 equals the sine of 47, which is the angle that we found over here, over 7, or below 70, I guess. So you plug this in, once again, isolate x just like every other time. So that'd be times sine of 51. And this would be out, and x would just be isolated by itself. So 70 sine of 51 divided by sine of 47 equals 74.38. So that is this side length right here. Okay, so next, this tree. Now we're just looking at this triangle right here strictly. We found out this side, which is what we needed, so we can ignore the bottom triangle now. So we use 74.38. This angle right here is 10. This makes a 90-degree angle with the ground, so we know that that's 90 degrees. So we can once again use the rule that we use down here. All angles of a triangle add up to 180. So 90 plus 10 equals 100. 180 minus 100 equals 80. So this angle is 80. So once again, use the formulas. Once again, we use the formulas. So we're trying to find this side. So we do x over sine 10 equals sine 80 below 74.38, which is what we got down here for this answer. So that, once again, do the same thing, isolate B. I'm gonna kind of move over here to where I have a little bit more room. So it'd be x equals 74.38 times sine of 10 over sine 80, just like we've done every other time. So then you plug that into your calculator. 74.38 sine 10 divided by sine 80, you get 13.11 to be your answer, I guess, meters for the height of this tree.